Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatan min lisani yafqahu qawli. The topic of my presentation today is about overlay design using FWD data. And this is a design Excel sheet. And if any one of you want to have it, then you can see the comment section. Generally, it is not easy to analyze the FWD data, especially nowadays when the Darwin software for 1993 method is not available because of the change procedures adopted by Aashto 2002. But I am sure there are many around the world who are still using 1993 method of flexible payment design. And when they have a data, FWD data from non-destructive testing, often they find it difficult to analyze it. So this is an effort to guide those people who really wants to use Excel for that. Uh, this is the, you can see an example, and this is taken from Aashto 1993 method manual. So what you need to do, there are yellow boxes and there are blue boxes. So yellow boxes is all about inputting the data you have. So what I can do is just change the data. For instance, I've tested a section where the asphalt course of varying course of 2 inches, maybe a binder course of say 6 inches, aggregate base course of say 12 inches, and granular surface of say 10 inches. So this total thickness is calculated. Uh, the load is applied during this testing. Let's say it's 9,000 pound. Um, some people may use different plate. So let's say the dia of the plate, the radius of the plate that was applied during testing was 5. So I change it to 5. And let's say the data obtained uh, at D0 in mils is say 5.5, and the data for D36 is the third plate is say 3.25. Now, once you have this data, I've this the MR, the effective depth, all these will be calculated. And this equation, actually, this H2 requires the depth of over the deflection at the center of the load plate uh, using this equation. So what we are going to do, since this is known to us from the data, and the unknown data in this equation is the effective modulus of the pavement that was observed during FWD testing. So obviously, this is not a linear equation. So we will use solver direction function to first calculate the effective modulus of pavement. The other equation for MR you can find from H293 method, and that's why this calculated automatically. So let's uh, so uh, let's apply this solver function, what you need to do is to say you have to input the trial value of effective payment. And if you know how to design a pavement, typical value for EP can be different. So let's say we assume it to be say 60,000 uh, PSI. Now what you need to do is to apply the solver function. So I will open solver and my objective is to minimize the trial error method. So I will first highlight this portion. Actually, this is the sum of square of error resulting from the difference between the depth calculated uh, with this data using the Aashto equation um, like this, and the the actual depth obtained this. So actually this value is the sum of square of error. And what we need to do by solving EP in such a manner that these two values, the difference between 5.5 and say 0.012, um, should be as minimum as it could be. So this is what we do. Now, uh, so it's just simply I've set my objective to be minimum value, and I want to change this value of EP. So you just have to select this value in your objective. And one thing is sure that whatever is the value of this EP, it should be actually greater than zero. So that's why I put this value. This value cannot be negative. That's why this is a constraint. So that the next thing you need to do is to solve this is the value we have used this one, and I have to solve by changing this value, and we say solve. So solution is obtained, and we find the value of effective payment is 168,165. So once this value is obtained, what we will do, our next target is to design the overlay thickness, to determine the overlay thickness. So we'll go from this EP value, we'll use SN effective, and this SN effective is calculated from this formula. Obviously, this is an Excel sheet. What I built in this formula so that whatever is EP value, this values for SN effective will be calculated. And similarly, Aashto has given guidance for designing the required SN value for overlay by using this formula. So this will automatically be calculated. So all you need to do is to just forget those blue lines, blue markers, the blue cells, and just focus on the values of the highlighted on yellows. Now, once you do this, now you are going to use this Aashto method design equation to calculate SN that is required uh, for the for the design of a new pavement, or you can say you can say this is an existing SN of the pavement. Now, how would you calculate this? Is you have to put the traffic that is expected to do this. So I can change for this problem. Say I say I am interested in 25, if my traffic is say 25 million. And I will know at what is, I also know that what is the PT value, what is PI value, and what is delta PSI. And if you are conversant with the Aashto design method, you know that for overlay, the required SL value is 0.49. And this MR for design is, again, you don't have to worry. This has been calculated from the data given here. So it's actually 33% of what is required. That's why I write 33% of this. So once you know do that, you will this use this equation. Now this is step number 2. Uh, Obviously, you don't have to do anything in this sheet. All you need to do is to this again. This is sum of square of errors. It says again this equation is an iterative equation, and we have to calculate the SN values. So that's why we have to again use the solver function. Now what you need to do is again go to the solver function. First you can do is say input trial of say 5SN, and uh, you will use the solver function again. Now this time your objective is by changing variable beneath here. And so I've just made this very simple so that whenever trial 2, you have to you only have to change the values. Yeah, so that's my objective function right now is this one. So I've selected this and I want my SN value to be calculated. That's why I say this value, what I've input, and then again I want this value. I will change this value. Okay. So what I can do is, oh, there are two cells, that's why it's not accepting. So let's select this cell once again. And my constraint now that the SN value, the SN value should be greater than equal to 0. So I change this value accordingly. And then I press solve to get this value. So now the SN value required is 5. I'll again check this thing with this value by changing the value of this, and I will take this value, minimum value from this data, right? And we go and we'll solve this equation. So my required SN is 8.376. And now, since my effective SN was 7.45, so I just subtract it and divide it by layer coefficient to get this thickness. So this is my depth of overlay that is required. I hope I'm able to communicate. It's just a simple Excel sheet, and you have to perform 2 steps. One for calculating EP, and the other is for calculating SNF of the depth of the pavement. The rest you will find this. Uh, the only thing that I have not done here is I have not applied the correction for temperature. This is very trivial. So I hope this will help you a lot in performing design of overlay of from the FWD data. Uh, Thanks for the patience, and I hope that this will help you a lot. Allah Hafiz and take care.